Hey everybody, Russ here with the CactusCon registration team. It's my pleasure to introduce our next speaker, Kuzushi. Kuzushi is a developer, hacker, consultant, and the Vice President of Security Consulting Services for Bishop Fox. Kuzushi's talk today is titled Reverse Engineering Websites. There'll be a live Q&A after the talk with the presenter. A link will be displayed at the end of the talk, and clicking on the link will take you to the live Q&A channel so you can ask your questions. So sit back and let's learn about reverse engineering websites.
Hi everybody, and welcome to my talk on reverse engineering the web or reverse engineering websites. My name is Andrew Wilson. I am a longtime security professional. Currently, I'm the Vice President of Consulting Services with Bishop Fox, which is a penetration testing firm focused on offensive security. I work with all the pen testers and govern and drive a lot of the work there. I started a project a little while ago called Send Security, which is looking at application security as something a little bit different, a little bit more than just a job, but like a craft, and really exploring what you could do, whether or not it's necessarily for the purpose of getting a job, but really to understand and own application security. So kind of a project that I've been working on the side. I am one of the co-founders of CactusCon. So this is actually interesting for me. It's the first time I've given a talk at CactusCon. In the past, I think I've announced people and in keynotes, and I think I've helped with a panel, but this is I believe the first time I've ever given an actual technical talk at the conference. So I'm excited to be able to do that today. Relevant for this talk, I was a software engineer for 10 years. The first half of my career was focused on application development. I've worked on academic universities. I've worked for startup firms. I've worked for big financial institutions, and I've solved a lot of really interesting creative problems with software engineering. And I was one of the first Microsoft MVPs in Windows Azure. The second half of my career, I spent working as an application security tester. Really, the first 6 years of the last decade, I was in the field, getting hands-on applications and tearing them apart and working with them. And it got me to a point where I wanted to use my background as a software engineer and this application tester to combine a problem I saw, which is that people see them as two separate things, even though they're correlated, right? There's no divestiture between security testing and software engineering. They're both a real science and an art together, and they work sort of hand in hand. This talk in particular actually came out of a conversation I had with a gentleman named Thomas Pacek. So for the folks who may not know him, he was one of the founders of Matisano, and he's gone on to other things since then. But we had this conversation about how security testing, first and foremost, before you get into anything else, is about what you can see, right? And I've always taken this to mean that if you came to me and said, "Hey, Andrew, I've got like $1 bajillion, how do we do the best possible security test?" I would tell you that I'd want a bunch of user accounts. I want access to the source code. I'd want to be able to sit on the server and look at how the systems interplay. I'd love to be able to watch network traffic. Every single thing you could give me access to puts me in the best position to approach this and use it to come up with the most creative, interesting problems and really get a deep understanding of what's actually happening, right? So reverse engineering in this context is, what do we do when we don't have that, right? When somebody says, "No, you can't, I'm not going to give you those things," how do we understand enough of the system to be functional? So it's sort of one tool in the toolbox, and I wouldn't say it's probably not necessarily the first tool you'd want to pull out. There's other ways you can go about getting visibility, but reverse engineering, for the sake of this talk, is what we're trying to kind of get into, what we want to explore. In practical terms, reverse engineering is not about trying to understand necessarily the entirety of the system, right? We're not trying to stare at our navel and understand the universe. We're trying to understand a system well enough to use that information to help us identify underlying weaknesses in it, right? And if you have enough context into what's actually happening, this can lead to really vulnerabilities revealing themselves, right? As you go through and you're unpacking the application. You can really see how it's operating, and as my friend said, the vulnerabilities become obvious, right? And the second part of that is that when you get down into specific unique exploitation against those systems, you actually need to have information in order to enable and help you to go through and do this and use it in a way that's going to make that reliable, right? You can't do advanced tests if you're just sort of shooting in the dark, right? You want to try to take that information and make it reliable, right? So we use reverse engineering as a way or tool to do that, right? For the purposes of this talk, I want to just take a quick step back and say this is not the same thing as taking a binary file and reverse engineering it into some sort of source code piece, right? For the folks who are not super familiar with reverse engineering, typically when you have a binary for things like malware analysis or competitor analysis, you just want to know how something works, you can download the executable, and then you could use tools to sort of decompile it into some sort of source code representation, which gives you a very clear picture or a very clear model of what's happening underneath the hoods, right? This is going to use fundamental principles from that, but obviously the mechanics are going to be quite different, right? The first mechanic that's different is that it's no home court advantage, right? We don't own this, we don't own all the environment around it, right? When you pull down a binary, it executes on your memory, on your computer, writing to your disk, and you kind of control the periphery, if you will, of all the things that the application is going to talk to and how it talks to it. And so with that, you can actually use it to imply and understand a lot of its behavior, which in our case, we basically get none of. We get the connection from our machine to the host, and then we could communicate right through that protocol. But beyond that and what's happening around it, we don't necessarily control. We can't see that in the same possible way. The second thing we don't have is a sort of a full picture, right? Web applications can be very complicated and have a lot of different use case conditions which sort of trigger and actualize behavior that you would never really truly kind of see unless you have ways to sort of exercise that behavior. In an application, right, in order for any feature to sort of work, it has to actually be on your computer, right? You actually have to have it execute and function as to operate, right? And so you tend to get a much better picture of what's actually happening in totality with an application. Now, that isn't to say it's exactly like that. There are some very complicated malware pieces that do segmented downloads, or they're packed, and it's very difficult to kind of get that picture right. I'm not trying to say it, but we don't have a lot of the same sort of tools in the same way to understand always the full scope. We're sort of left with a lot of incompletes, if you will. And the last thing is that there's no set standards. There are standards, right, in the sort of cute little, curly braces, right? It's not, we have ideas of what should happen on the web, and then there's the reality of what's happened on the web in order to support, thousands and millions of people building web applications and browsing them, and a long history of what that looks like, which has created kind of this beautiful mess that is the internet today, right? So that we do have patterns, and we do have things that people commonly do and use, and that actually becomes really important as it's the foundation of the methodology we're going to use to actually reverse engineer web applications, right? And the modeling system that I have for it is composed of three things. First is this recognition prime decision making, and the second and sort of the third is what we'll call scientific method as one bucket, but inductive and deductive reasoning and methoding that we could use as a way to unpack things, right? Starting with recognition prime decision making. Back in the 90s, a gentleman named Gary Klein was approached by the military to help solve the problem of teaching battlefield command how to make decisions under stress with incomplete information and be accurate in doing so, right? Time-gapped, incomplete information. They had used a model before where they had tried to teach battlefield commanders through what other people were doing through flow charts and flip charts, and what they found is that it never really sort of worked well. In fact, the opposite, it kind of worked to the detriment, right? So how do you pack that out? So what Gary Klein and his team did is they actually started to investigate people who have this problem today and do it well. So they went to chess players, they went to firemen, they went to nurses, right? And all of this idea of how do you triage? How do you solve speed chess? How do you solve chess in general? How do you save people from fires, right? And they said how people make decisions. Hopefully we can sort of glean something out of this and then use it to become a training methodology to then pass along to other people to help them also make it. And that's called recognition prime decision making. So what they found in this process was that through these interviews, the most common answer they would run to is, I didn't make a decision. I just sort of knew what to do. And while that's actually really quite, fascinating from sort of a cognitive perspective, it isn't necessarily transferable in the same way, right? It's obviously not the best system. And so with the right sort of poking and priming and questions, what Gary Klein and their team came up with is this system that kind of flows out over here, right? In the way that we see it today. And what he found is that people are looking at situations based on what they understand of all the levers that sort of make it happen. And then the ability to combine that becomes a very natural extension to the point where when they just see it, they go, I just knew what to do. And for anyone who's spent a lot of time with a particular skill, whether it's driving your car or a hobby, you know what that feels like, where you just sort of know, right? And if you ask somebody to explain it, you'd explain it to you or explain it to someone else, you'd be very confused, it'd be very complicated, right? And what Gary's team came up with was this, and this is a system that we're going to use, right? So which is why we're calling it out here, right? And it starts with, is this familiar, right? If it's not familiar, if it's not resemblant of something you've seen before, obviously that's problematic, right? And inside of that, you go through this loop of trying to make it similar to something that reassessing the situation. You sort of get stuck in this initial loop where you don't understand enough of the pieces that go into it. Firemen, as an example, study things like, how do fires start, different nature of how flames work, how buildings are designed, how smoke can indicate pieces of things, so that when they arrive in that situation, they're not stuck up here in this, like, I've never seen it before phase. They've seen it, they understand the pieces, and they're able to combine it and turn it into something useful, right? From there, it turns into this, I've seen it, it looks like this other thing, I think it's this thing, and it starts to operate in this recognition pattern of like, is it meeting my expectancies? Is it doing what I expected it to do? Do I get the relevant cues? Meaning like, if there's a timing to stuff, if there's a specific order in which how it happens, you begin to pick up these pieces. And from that, you can have a very sort of close similarity process where you take sort of what's happening to what you think might be happening, and you have a really good way to evaluate and understand the situation side of it. From there, in terms of what you actually have to do, then you go down this path of like mental simulation. What if I try this? Will it work? How will this break out? That's a sort of different portion, but this is how we start to recognize problems inside of applications. The way I like to explain it is that when you're looking at source code, there's going to be a lot of things that are what I call architecture, infrastructure that support the main primary gist of it, right? The custom code versus the infrastructure, the architecture, framework code. And if you can't tell the difference between those two things when you're looking at it from source code review process, or even just how an application is behaving in terms of like a CMS or commonly behaving through a React application, it's really difficult to start picking up on those cues to go, hey, what's going on here? What should I be paying attention to, right? When I tell the story as I was driving to go see my friend. He just bought a new house up in the Pacific Northwest and was driving, to go see him. He had great directions all the way until I got to like the last point. And he said, just drive on this road. I live off of hidden sort of valley road, if you will, and go there. But I didn't know some of the other things that I would be looking for, other pieces of information, like how far it was, is it on the left side of the road, is it on the right side of the road? And so when I took that into account, I took the name, right? It says it's Hidden Valley or Hidden Ridge or whatever it's called. And I'm driving down the road. I have no idea how to differentiate or when I should be paying attention to what's relevant for the problem I'm trying to solve. And so I think he lived maybe about 1.5 miles, 2 miles on the road. It took me almost 2 hours to get to his house. Every single side road that popped up on the left and the right at night, right? You're looking and you're going, oh my gosh, is this a street? What if you miss it, right? And as it turns out, I get to his house and he's got a gigantic sign, that says, oh, welcome to Hidden Ridge or whatever. And I was like, ugh. But the point is, when you have the patterns, when you understand the levers, when you can sort of grok what's happening, it makes your life significantly easier in trying to unpack how an application is going to work, whether it's a compiled binary, whether it's a web application, because you intrinsically sort of know the shape of things, right? The second thing and the third thing that we talk about in this system that we want to like go through is this idea of inductive and deductive methods, right? Or ultimately the scientific method, right? The inductive method is popularized by a guy named Edmund Locard, or the Sherlock Holmes sort of pieces you've run into it, which says that anything you do leaves trace evidence of what's happening, right? And from a bottom up, you basically look at what something is doing, and then you collect that to come up with a frame that says, if this happened, if this is here, then this is probably also here. And you sort of work your way up. This is the Sherlock Holmes, like breadcrumb. Transference theory is another term for it, which says anything you do leaves an evidence of it. And when you look at an application, right, in the context that we'll be doing in just a minute, you can actually use this as a way to create compelling stories, to create the questions around, well, if this is here, then what about this? If this system and this system communicate, how would they communicate? And you can start to build breadcrumbs to determine what's actually happening in the application. Deductive method, on the other hand, is almost the inverse of the inductive route, right? Sort of a top-down approach that says, like, if all men are mortal and Socrates is a man, then therefore Socrates is probably mortal. He has to be mortal if all men are mortal. And so you take a general theory and then you reduce it and you reduce it and you reduce it until you can apply, if this is true and this is true, then this also must be true. And you work your way sort of down from that system to create your stories. We use both of these to start to teach ourselves how to ask questions of an application, so that as we're sort of interacting with it through live testing and studying the results that come out of it, we basically know like a route to form the questions that are going to teach us what it's actually doing, what it's doing for real, right? Or well enough so that we can apply our exploitation or apply our techniques and tools to it. So with all that in mind, I promise we're going to get out of kind of theory land. I want to talk about sort of the first pattern because it's relevant, right? And that is basic application design. We talked about how there's no like real sort of protocols or pieces that you sort of thou have to. There are a few commonalities in things that are generally true, and sort of with that, it all kind of gives you starting points to drive it out. And the first and of course easiest one on this is this idea of a basic application design. Right, so all applications have some context of what is a presentation tier, a logical tier, and a data tier. Right, the presentation tier is what it sounds like. It's not just how data is brought back up that you can kind of see, but it's also the inputs that come into the system and the way that you interface with it to put in inputs to drive the logical tier or the business logic. This could be as glorified as a console, like a console application, or it could be a gigantic website with, React and different sort of APIs that you actually might be using for your cell phone, right, in terms of interacting with it. But you could have really complex presentation tiers. Logic tier is the behavior that's behind it, right? So, and sometimes this is an API that has business functionality, but think of it as if I was going to go make a transaction and I want to put money into my bank, there's some routing rule, some business logic that takes that information and then transfers it out. And it decides like, where's it supposed to go? Why is it supposed to go there? How much? And the rules around like, oh, you don't have this much money, right? There's ideas, right? Business ideas in it. And then finally, there's some sort of persistence tier or some sort of data tier that actually lets you store, right? If you put money in a bank, obviously there's a record of it somewhere. Applications sort of follow this through. This is sort of your very typical life cycle of a request. It comes through presentation, logical data tier, and then it kind of works its way back up to the top. These are sort of fundamentals that sort of drive behavior, and no matter what you do, right, no matter how bad of a programmer you are, these things actually almost always exist, right? Unless there's no persistence, which you could actually drop the data tier, but there's always something that kind of goes through this way. They could all be merged together. They could be very concrete. They could be very complex, right? And so with that, we take this very simplistic application tier, and we start to look at what a modern deployment might look like for a web application, right? And so this is something from Amazon to talk about how to scale your application. And because the needs that people have in these applications has changed over time, so has the complexity associated to it. So you have this web server, which in this case is sort of a presentation tier. You have an app server, which very specifically is my logical tier. And then you have databases, right? And it sort of has this route sort of here. This is what we just looked at the last slide, but there's complexity that comes into it. When you have something that has a lot of traffic, you need load balancers. You need to be able to scale it horizontally. So you want to add additional web servers to handle your presentation tier, or different app servers to support it. And so there's scalability that happens in here in order to grow. You also have the introduction of something which is called a cache, and you have a cache here. You also have a cache basically through this sort of CDN type of network, this Amazon S3 bucket, which says for content that doesn't need to change, meaning maybe I stored it one time through a system where you input it, it comes down, it gets stored in the database, they might push it in the cache so that anytime someone requests it here, instead of following the same sort of full cycle, it actually goes, oh, hey, I already know I have this inside of my S3 bucket, I could just serve it out of this, right? It's sort of static content, you can do things like that, or content that doesn't change often. The other thing that I'll call out here, because again, it's relevant to what we're kind of about to go take a peek at, is this whole secondary piece. So modern applications are actually quite complex. You have to be able to know what's happening with it in real time if you're monitoring it externally. And so you have these things like notification systems or email systems or alarms or alerts or logging that all kind of exist sort of to the left, if you will, of the actual application that may be contained in a whole other app tier, so that when you're working at home, you can log in and see like, how is this thing behaving without having to get onto the server itself, a sort of external monitoring type of support. So this is just a modern way to look at this application tier that we talked about, but some of the conventions you are almost assuredly going to run into anything of complexity. So with that, right, for the rest of the talk, I want to get into very specifically a website, right? And I'll just say normal cautions sort of aside, this isn't a pen test. We're not doing anything crazy. It's a public website. The source code for it is public. You could look at the Wikipedia code to sort of evaluate, did I say something true? You can test your assertions with it. So a great place to look at it, but we're not pen testing anything. No kittens were hurt in the making of this penetration or looking at this test here. We're just trying to understand it, right? So with that, we got to start asking questions. We could take this sort of inductive route that we talked about before, this top-down driven sort of approach, and we could say Wikipedia, we know a fair bit about it. We know that it's a very popular website. We know that it stores a bunch of different articles. We know it stores articles by language. And with that, we could begin to just make some very general assertions, right? Wikipedia, I believe, is like the 9th most popular website on the internet, which means it's very likely that they're going to have a caching tier that supports a lot of the traffic that comes into it. Because if you had to make full round trips for all, the people who came in to look at it, you would run out of infrastructure really fast. And so having it very responsive is a big deal when you're building a site like this. So you can assume caching happens. The second thing you could actually assume is because, based on this website here, just kind of taking a look at it, that, you have English articles, you have French articles, you have Dutch articles. They all sort of evolve separately from each other, meaning that they all have their own content relevant to what there are, how you get homed, how these things work, how, those connections go to. There's some mechanisms you can kind of guess, right? But by and large, we have a sense that they evolve separately. And the last thing we would say is that when you go and you look at any of these, you're going to see that they're all basically the same looking, and it's very safe to assume, especially given the fact that the source code is in fact public, that this is one body of code. And it's not like the French version is completely different than the English version, or the Italian version is different from the Dutch version. They are probably using similar instances, if not the exact same type of code, deployed in different places. Now, they may evolve independently, so you can't take that for granted, but you could assume that there's a common source code already between these, right? So if you look at the English one, you have a pretty good chance that the things you'd be looking at would be relevant in all the other servers, right? And that's a lot of information before we've even sent it a single request, right? if we take a look at the request and we start to take a look at what comes in from the response headers that come out of this, what you're going to see is that some of those general assertions we made are already provably true, right? So one, they're running Apache traffic server. You could see that it was served from a cache. You could see here that there's actually some naming of the infrastructure, and it very blatantly tells you like, yes, I pulled this from a cache, and where did it hit in the cache, right? You can see in this report to infrastructure that they use NFL or NEL, excuse me, and it's a way to transfer information to the side about events or things that are happening. So there's very likely some infrastructure that's going on behind it for logging in the side that may be relevant to use if we want to do channel attacks against some of these things later. And then you could see that they have cookies that sort of home people, right? So when I click on the English site, it says, hey, you were here last time. It's not on this particular request only because it's a 304 not modified. I was actually on it before, but they set a homing cookie which says, oh, this person came in from Phoenix, therefore they're probably in the United States, so they want to see United States traffic, right? And that's a lot of information for just one request. We've confirmed, like I said, everything's from the cache. We identified the technology of the cache. We figured out how they're tracking us through cookies, right? And once it's set, does that mean it's set forever? Can we just delete it and, change it through GeoIP spoofing? There's a lot of stuff that we already know how to start to control some of those outer perimeters to help us get information about how Wikipedia works, right? What we don't know out of this is how would you get to real servers? Like, how do you get to the dynamically served stuff? We saw it pulled it from a cache, but what other ways could we get that from there? We don't know if there's other servers in play, right? And then again, we tried to see if geography, what is the effect that geography has in terms of what's served to me? But that's just because we're only still really on the first request, right? From here, you could click on the English site, right? And you will see that it brings you to a landing screen that looks very similar to this. This is back in November when I first put this talk together. But you can see a couple of things. You could see that it has information about a feature article for the day. It has some news. It's relevant news to my geography. So when I logged into this system, even to the English site, and it thought that I was logging in from Japan, it started to serve Japanese relevant content. And so how it determines what goes into this page is geographically homed. And we've seen how this piece kind of plays out. Now, you might be thinking, well, because it's pulling date, right, relevant information, that this would probably be served dynamic, and you would be wrong. This, in fact, was actually served from the cache yet again, right? In this case, you see some new servers, so that's interesting. We know that there's some more servers in play here. We know that there's some sort of location piecing around it, and more specifically kind of down here in this bottom, you see the name of the page, which is where we ended up going, right? And that's fine, right? What is really interesting when you look at the website and you start to evaluate it is that we requested this page, wikipedia.org/wiki main page, whatever, right? But in the view source, when you actually go through and you just kind of take 2 seconds of poking through it, you'll see a different URL here that actually goes through this w/index.php, title, PHP, etc., right? And so you could be curious and you can kind of poke into this and realize that these are in fact the same instances of the page, right? It's one page served with 2 different URI structures. And that's confusing, right? If you've never looked at web applications before in this way, like, what does that even mean? Like, why would it do something like that? The answer here is sort of a patterns book. And if you want to get familiar with patterns so you can start to unpack these applications faster, I can't think of a better book called Patterns of Enterprise Application Architecture by Martin Fowler. It was written a long time ago, back in the dark ages, but it's a continuation of this idea of the Gang of Four books, which are enterprise ideas that say that developers tend to follow common patterns to solve problems, intentionally or otherwise. So what if we took these ideas of patterns and we tried to define them to help us sort of stand on each other's shoulders, learn better ways to do this, and then actually use that in a relevant way to go after and teach people, right? So this pattern here with 2 different URI structures turns out to be what they would call a front controller. So front controller is this basic idea that if you have a single page, right, this index.php in our case, or page.php, and then from your query string parameters, you set an action and then all the parameters that associate to it. It gives you a breakout of all the different requests that actually would be related to it, right? It's a common handling mechanism. And it essentially acts as the route that says that when a request comes in here to index.php, you actually want to go to a function or an action named X and then pass it the following parameters. It also means that given the frequency that you're going to see this inside of Wikipedia, it's probably the primary method, this index.php action equals what have you, is probably the primary way that content is served, and that the other route is more of maybe a regex or an alias or some sort of routing mechanism that says that when you see this, go realistically call it from here, right? What's interesting even more about this, right, just from a pen tester perspective, is that they've introduced a lot of different ways to go after this application already with just this one sort of design decision. Now, not necessarily a bad thing, right? But it means that the way that you communicate with it is radically affected in just sort of the smallest sort of nuanced way. But things like if you have a path, right, a path is expected from a UI perspective. You have a scheme, you could put in a username and password. Back in the day, I don't see this too often anymore. It's possible. You have the host, right, where you're going, what port you're going to. The default will be 80 or 443, depending on SSL and so forth. And then you have a path, which says like, to get to a function, I'm going to go down this path, and then I'm going to have a receiver typically at that end. In this case, you can then append parameters from the query string or fragment, and they all give you routes to communicate with it. By having these two routes, what you have now is the ability to pass in a value through a query string that simply wouldn't be valid if you wanted to manipulate it from a path. If you only had, for instance, this path data and no query strings, you couldn't say pass it, path/data/path.data. You would have no way to actually send it because the UI structure would actually think you're requesting something else completely off of the server. So by having these two routes, you now can do things you couldn't otherwise do, right? And with that, you see that this pattern happens all over the page. It's everywhere you could see it, right? So you pass in a title, the title gives you a page name, and then you have the sort of functions, right? These functions are really interesting from a reverse engineering perspective because some of them appear to be across everything, right? So this return to functionality, this could be some sort of generic code base that's handling the event piece or is attached to all of these. You see a return to query. You can see all these different function sets that you can actually use this now to create a map of the application if you really wanted to that says for all of these actions, these titles, and you take these parameters, you can build almost a real functional map just looking at it kind of here. From our instances, right, just taking a peek at it, right, we're sort of digging into it and want to understand how this thing works. You see that there's another page that's download as PDF, and you can pass into it the main page and then say action show the downloads group, right? You see how it works. And on sort of further review, as you get into it, you will see that this in fact is yet again the same save page served as HTML or it's served as PHP. So now I have basically 4 ways to get to the same site just by ultimately looking at 2 pages. I haven't really looked at anything other than those 2 pages, and then I confirmed it through a user page only because this particular user banned me, but that's neither here nor there. It's an automated bot. And I wanted to see how this worked, right? So we just played with it to kind of play it. You can take this even a step further, right? We talked about the functional map. You could play with it that way, but you could also create a logical map. And the logical map looks something like this, is that you have inside of it this sort of routing table, if you will, right? It's going to say, hey, when this request comes in, there's some sort of URL rewriter. This could be in the source code itself, right? It could be a part of the PHP code. It could be on the server, right? We don't know. There's ways that you can detect this, not relevant for our talk, but we know that it exists because this, by its nature, routes to here, right? And we get to this piece here, which is actually the real function. So with this, we actually, to the point before, have now 2 different ways to manipulate and modify and play with it. And we have a bunch of different parameters that could have direct impacts on how the user ST47 page works, right? This other page here actually does something else really interesting, which is you pass it a page you would like it to look like. So in this case, I sent it the user AST47 or ST47 piece, and then you can push it over to the download as PDF. That also means, right, by just taking a peek at this, that I know that some sort of PDF converter exists if I follow this logical route that won't follow in this logical route. And you could continue to take this path and dig it and dig it and dig it a little bit further, right? You could actually unpack whether or not this is a URL rewriter that's in code, or you could check it to see if it's something that's like a mod rewrite or something on the server itself. And you could start to build assertions by creating dedicated tests. And again, we've only looked at really 2 pages, 3 pages with very little sort of time investment into this, right? The next thing that we could take a look at is we've figured out, language of the website, right, is PHP. That's pretty obvious. We've seen basic requesting patterns. We've seen the name of very specific functions. And so, you have this and you have a bunch of pages that are very similar to it. The super user account is at ST47 because, like I said, he banned me. And then you could see like, hey, are there other interesting pages that divert functionality, right? Like clearly this page here diverts the functionality from one place to the next. And so it could be other pages that give you yet another way to access this. And you don't know, by the way, what the permissions are. If I make this request comes through my browser, comes to the server serves it to me as either anonymous or through my ID of some sort. When I make this request, there's no guarantee that the authority who makes this request here to go get it is actually happening server side, right? So it could be a whole different user authority. Is it taking my authority and passing it through? Is there a generic user account that's behind it in order to access it? Like, how does it know I'm not supposed to pull this? Right? I'm assuming there's some sort of off pass through here that gives you yet another piece of code that you can start to play with, right? So we never really figured out how to break the cache. We're trying to figure out how to break the cache. It's obviously a big piece of what we were looking at here. We wanted to kind of see how you could do it. And one of the things that you could do to break cache is start to ask questions of what type of requests would create content that's new, right? Because if it's new, presumably it wouldn't have time to propagate out to all the cache entities, right, the next time you requested it. So really the easiest way to do this would be to create something new, right? And so what I did is start playing with the editing pages. And in this, I found this sort of load.php, which follows, again, a very similar pattern to the index.php. But in this case, you'll see that it actually only supports pulling in JavaScript files, JavaScript libraries, and then it's used for this process of creating something new. When we get here, we run into, again, I'm on this server. It misses the cache in and of itself. And with this, I've actually found the very first instance where as I'm making this request, it actually is talking to a real sort of server, things of this sort, right? So going back to this page, we started to talk about the different request structures, right? So we've looked at it from this idea of the front controller, but as you explore how this particular page works and you start to take a look at it, when we look at the request process, you see it broken up in something more like this, right? And with this controller, you see that there's a change in technology. REST is not a front controller. So REST is this RESTful API, right? It's a way to replace SOAP, and it was very popular back in like 2008, 2010. And it means that it's a whole different code base, most likely, underneath this piece here, because it's not actually using the same technology that the previous one did. It actually is using get and head requests in order to go pull out and get this information for you, right? So now we've seen another server. We've seen a second piece of code structure, how the application itself behaves, and we've seen new ways to access the same thing, again, just by spending a little bit of time with a little bit of inspection. The last thing in terms of sort of interesting pieces is we ran into this idea of a beacon. Now, I looked at a lot more of the source code, and so I saw some of these requests play out, but we see a URI here that violates my pattern of how the rest of the site works, right? We started with you have a request URI, it goes to the front controller, we saw the RESTful controller, and now we see something totally different here, where it's literally just calling a beacon event, and it's passing all of this information along to it right from the URI. That's not the same thing. In fact, it's not even on the same server. It's on a varnish server. And so you get a question like, how do you get here? You see over time, for people who've been doing security testing, that applications evolve through their iteration, right? They go from sort of original inception to plugins to additions, etc. And so you start using these as basis to go, well, this might actually be perhaps, a plugin. It might be a different code body. And with that, it creates new opportunities for testing and kind of continuing to unpack this, right? This particular design pattern, going back to the Martin Fowler stuff, is what we would call a page controller pattern, right? And so in this, the page is the controller. When you go to the action, right, an edit page or an update page or what have you, in this particular case, it is most likely a page controller, meaning that the functionality for it exists within that one page that you've went to. So if you go to edit user page, that's typically one thing. If you go to delete user page, that's another thing. And so you actually have everything inside of it to do it. My point in drawing your attention to these things is that these all become levers, right? Just like we're talking about vulnerabilities applied to the mechanics of the application, we're trying to understand how this system works in its totality so that with it, we have the capability of driving an understanding that dictates where we're going to ask questions, what questions we're going to ask, and we can begin to peel back even more and more and more and more layers of this application, right? So as an example, right, to really kind of give you some context into this, what we've been able to see just through the little bit of testing we've talked about is that you have a caching inspection group right here, where we talked about the caching on our previous Amazon model. And so we see that there's basically 5 different caching entities in place, or at least 4. This idea here of the EQAIAD, whatever that is, actually is where the dynamic content appears to actually be served when it misses a cache. We know how those named conventions work. So if we're actually writing exploits later, where we're looking at things like cross-site request forgery or cross-site server forgery, we're trying to talk between the servers and we're passing our requests between things. You know the infrastructure and how it works, so you can communicate with it and you're not guessing, right? Or you could enumerate it even further so that you have very targeted specific things that you're going after. We know also that you have basically 3 bodies of code, right? You have this beacon extension thing, you have this front controller, which is our primary method, and then we also have this semi-dynamic RESTful sort of piece inside of it. This gives us a lot of information about the composition. And again, this is really only with, again, we talked about it now for really the last 20, 25 minutes, but it's really was about 5 minutes of work to understand what this looks like and play with just by going to the website and navigating through a couple of things and reading through source code on it. The last thing we learned is that they have logging as an infrastructure to the last piece. They have this thing called an XID, which tracks. It's a GUID. It looks like that information might get passed over to logging, or there might be a way to communicate with it. And so if you were going to be building custom attacks, you know that this logging exists, and you might find it relevant, useful for sort of second order attacks or second tier stuff if you go down that route, right? There are some tools to make this easier, right? So I've approached this from the perspective of, if you take the time to learn how the patterns work, right? The levers, how does a website look? How are they modernly deployed? With that, we can start putting together and assuming those components, but recognizing not everybody has 10 years to want to become a professional tester, software engineer before they go start in testing. You can use things like Wapalizer and get very similar ideas, especially when there are common pieces inside of it that kind of identify it, right? So knowing that it's MediaWiki, if I ran into this, in the wild on a real engagement, I probably would just download MediaWiki, figure out what version they were running, and then I would use that as my basis of comparison. I may not even try to reverse engineer it because it would almost be irrelevant at that point, since I have the source code here, and that is how it behaves, right? You could use it that way. And so having this access to what they actually are doing, and maybe versions, as you can see, right, to the jQuery and Moment and Migrate and so forth, that gives you a lot of information that can help drive some of it. But again, it didn't tell you the front controllers, it didn't tell you page controllers, it didn't show you the caching infrastructure, the caching architecture. And so with that, there's limitations to something like Wapalizer. However, things like Wappalizer can kind of take some of the guesswork out fast. It can kind of help you move down this road and make your life a little bit easier, better, right? So from a takeaways perspective, right, core concepts, things I'd love for you to leave with, right, is you have this server-side request forgery attacks, possibly through the PDF download functionality. You might be able to make the server go request other things, right? So like, what's to say that that function we saw for download as PDF is only restricted to that server, right? So if I'm looking for SSRF, I'm looking for areas where the server is making requests on my behalf. So knowing that's what it's probably doing here, could I go send it to Google? Could I go send it to a server that I control? It would be probably how I test it to see if there's a possibility for that to happen, right? We know what the cache systems are, and so we might look at ways to do cache poisoning or other HTTP-based attacks that might bypass the way that the auth and the cache itself works, right? Because when it's cached, right, how that information is cached and what goes into it may very well have a whole different authentication. Like, how would those two systems independently evolve? Again, probably not a lot of private information behind it, but there are attacks that you could go through and take advantage of the fact that you do know that a lot of that's cached, and they could probably use it to attack people, maybe other people indirectly through second order attacks. You could map all the functions, like I said before. When you see something like a front controller, knowing that every action basically represents a method or a class, and then inside of it you have the parameters for those calls, you could actually basically reverse and just literally write out the entire function map from there and then start to play with it. So if I was to do a real test on MediaWiki, what I would probably do is I would enumerate as many of these as I could to see what additional sort of functions were there, what other parameters they took, and then I would create a master list and I'd repeat all those requests and take the parameters that I've seen already successfully and see which ones are universal, which ones are specific to them. When you run into common naming conventions, these tend to actually reveal different types of parameters that you can manipulate, similar to like a mass assignment attack, if you will. And you have a tool that's going to give you some way, some information to do it. Now, again, not relevant in some regards because you could go download MediaWiki. You don't need to go guess, right? You could just look at it, but this is what you would do if you didn't have it, right? Again, we talked about attacking the logging server, right? If this was an attack, if I was going to attack Wikipedia, you could maybe go after a logging service and see is there a way to like poison that through second order cross-site scripting and ways to do callbacks, things of this sort. The point of this talk, and ultimately what I wanted to kind of go through with everybody today, is that the scientific method, it still rules, right? And that you can't put something on the web without some way for me to figure out how it was composed. Even if you sort of hid some of the headers, even if you didn't actually be so explicit on things, it would be not that difficult to figure out the differences and deltas between what comes out of cache based on things like how fast it responds, how long it takes for some of your requests to come through can actually give you indications. As you see through things like blind SQL injection, you can create predictability through your test to determine what's actually happening on the other side, even though you don't know what it is, right? This whole system relies on your ability to understand patterns, right? And you need to be able to look at the lever points so you know where to apply pressure appropriately and what you can basically ignore. There's some pieces of this that I would just say I haven't looked at the technology in a long time, and so maybe they're false flags, right? Maybe it's I just don't understand how the technology works, and that's okay. But the goal would be to reduce that so when I'm looking at a site, I could go through it faster and faster from time and again, and then save my effort and my energy. So when I look at it the next time, I'm not guessing as much, right? And it makes me much more rapid as I do this, right? There are violations to standards, right? So you could have this URL rewriting policy where sometimes it's a query string, sometimes it's a path. That's really clearly not what the standard was trying to kind of shoot for with that. But it allows for ambiguity that now creates nuanced testing approaches that may not have otherwise been available if they had just stayed within the standard or the way that the spec itself was written. But again, to my point, even at the beginning of this, is that the standards are very loose, and there's a lot of things you can do because the web technology is quite flexible, right? And then finally, when you introduce new code patterns, right? Whether it's the RESTful API, the front controller, the page controller, you create unique opportunities that exist only in those isolated buckets. And to the degree that you can even just understand how an application works at these pattern level, you actually have a leg up in coming after this and then using it as a way to drive an attack and go after systems and really use in your time intentionally and focus your time in your reverse engineering efforts. So I hope this talk was useful. I'm really thankful to be here. If you want to learn more about application security from me, jump in to sendsecurity.io. I have a blog there, and then I have a YouTube channel that I am woefully overdue in putting out another video. But we're going to continue to explore these types of topics to help people become better pen testers so they can write more reliable exploits and find things more reliably too. So thank you all for your time. I appreciate it, and hope the CactusCon continues to go well for everybody.